Hi, welcome to video 7.1D, end of area. Okay, so this is numbers 83 through 84. It says find B, this typical AP question. Find B such that the line y equals B, so this is mystery B, divides the region bounded by the graphs of the two equations into two regions of equal area. So we're doing 84. So here's y equals the absolute value of x, negative absolute value of x turns down, plus 9 moves it up 9. As far as the x-intercepts, if you replace y by 0 and solve, you'll find the x-intercepts are at 9 and negative 9. So here's what we have. We have this region, this triangular region right here, and they want to draw a line y equals b, which is a horizontal line that's going to divide it into two pieces, not two pieces that are congruent to each other. Obviously, the top is a triangle, the bottom is a trapezoid, but two regions that have the same area. So what we want is we want the integral, first of all, the integral from negative 9 to 9. This is, although my picture doesn't look like it is a symmetric figure. Half the triangle's over here, the other half is over here. So first of all, we agreed that the negative 9 to 9 is the same thing as 0 to 9. 2 times 0 to 9. Okay. And by the way, if you are on the right side of 9, you can drop the absolute value of x. I integrate, blah, blah, blah. I get that the area of the whole thing is 81. But what I want is I want to draw this line y equals b so that, for example, this top piece, I'm going to take the triangle, has an area of half of 81, which is 81 over 2. So the area of this region, it's bounded on the left by, now if that height is b, if you plug b into your equation, you'll find out that x is plus or minus 9 minus b, which is 9 minus b, negative 9 plus b. So when you plug b into the equation for the v-shaped absolute value, the x-coordinate is negative 9 plus b. Over here, it's 9 minus b. So our left border is negative 9 plus b. Our right border of our shaded region is 9 minus b. The top border is our 9 minus absolute value of x graph, and the bottom border is b. Now, as we said, that's 2 times 0 to 9 minus b, so we can do it as 2 times. And that will give you 2 times, and if you integrate that, that's 9x minus x squared over 2 minus bx, evaluated, blah, 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 and you'll eventually get b equals 2.636. The other way of doing it is to just let the calculator solve the whole thing and actually ask it. You still have to figure out that that's the negative 9 minus b and that's 9 plus b, but you actually set it equal to half the area and then comma b, and it'll solve for b. 89 to 90, find the 2 points of inflection. Determine the equation of the line that intersects both points. Calculate the areas of the 3 regions. Okay, so they give you a very ugly long polynomial function. Here's its first derivative. Here's its second derivative. Second derivative is 0 at negative 1 and 1. And if you test it on a number line, sure enough, the concavity changes. So there's a point of inflection at negative 1 and another one at 1. And there's the y coordinates. So now you want to draw the line through those 2 points. You find the slope. There's the equation of the line. And yeah, pause. Okay, so so we have y equals 3x minus 11 is the line that goes through those 2 points of inflection, these 2 red points right here. Now what happens is if you draw the curve, which by the way use the TI, you end up with 3 regions, and that's what they want. So the region, you'd have to find the point of intersection of your line. Again, use your calculator to solve the system. You have y equals 3x minus 11 and then this big ugly polynomial. So you'll find out the points of intersection are at negative root 5, negative 1, 1, and root 5. And then, of course, top minus bottom is line minus curve. The next one, top minus bottom, is curve minus line, and then line minus curve. And surprise, surprise, these two are equal, and their sum is equal to the middle. And who cares? I really don't know who cares. And